Hi, in this video we'll be discussing GMAT Official Guide 2017th edition Quant Problem Solving question number 40. Let's have a look at this question. So here the question says, if n is a prime number greater than 3, what is the remainder when n square is divided by 12? Alright, so very simple straightforward number properties question. There are two ways of solving it. Either we can do plugging in here, or we can also, if you know the definition or if you know the property of a prime number when divided by 6, we can also use that property to arrive at an answer here. Okay, so let's first see the plugging in way, but before we start, all we need to know here is some definitions, right? So some things here, right? Say what is a prime number? So prime number means what? Any number which is divisible by 1 and another factor which is itself is called as a prime number. A number which has two distinct factors, which is 1 and itself, is called as a prime number. Prime numbers is always a natural number, is always starts from 2, and 2 is the only prime number, right? Now they have given us a condition here, n is a prime number greater than 3. So greater than 3 prime numbers are what? 5, 7, 11, 13, 17, keeps goes on, 19, keeps goes on, right? So now the question is, what is the remainder when n square is divided by 12? So what is remainder? Remainder means when we divide by some factor or when we divide by some dividend, the whatever the leftover. For an example, when I divide 26 by 8, here the remainder is 2, right? When I divide 26 by 8, the remainder is 2. Otherwise, according to the division algorithm, you will write this as 8 into 3 plus 2. So that is, any number is always equivalent to its divisor into quotient plus remainder. And also, remainder is always lesser than the divisor. Remainder always has to be lesser than the divisor. If remainder is 0, then we say the number is divisible. Okay, all these things are there. Now the question is, when n square is divided by 12, what is the remainder they are asking? Suppose if n is like this, then let's square this. Let's square the first few elements. So n square would be here 25, 49, 11 square 121, 13 square 169, 17 square is what? 289, right? So you can write that, right? So if at all anybody have difficulty in finding 17 into 17, just do it if at all you have trouble. 7 sevens are 49, 4 7 sevens are 7, so you will have a 11 over here, and you have another 7 and a 1, so it gives you 9, 8, 2, 289. That's it. So now just quickly divide this with 12 and check what is the remainder. So 25 when we divide by 12, right? 12 2s are 24, remainder is 1, of course. 49, 12 4s are 48, so remainder will be of course 1. 12 10s are 120, of course the remainder will be 1. Then 12 14s are, that is 14 12s are is also 168, right? So the remainder is 1. Then you will have what? 12 20 times is 240, so 24 into 12, right? 24 into 12 is 288, so that means remainder is again 1. So if you look at it, if you see all the values when you divide by 12, the remainder is 1. So we can choose that remainder also, remainder has to be here 1, answer choice B we can choose. But if at all, if few students have small hesitation, you can just try some bigger number. Say what bigger number? So I'll try here 29. What is 29 square? 29 into 9, right? 9 9s are 81, 9 2s are 18, so you'll have a 26. 2 9s are 18, 1 balance here, 2 2s are 4, 5. So you'll have 1, 14, then you have is 8, right? So 841. 841 when you divide by 12, of course the remainder has to be 1, because 12 70s are is 840, that is 12 7s are for 84, so that means you'll have remainder is 1. So you can conclude that here remainder is 1. You can be very confidently pick the answer as B here. There is no other answer choice no other answer choice can match here, right? So all you need to do is pick some values and check the pattern. If the pattern works, it has to work for all the values. Some students always think about, okay, how long should I test? See, this is how you do it, right? I tried some numbers which are 2 digit here, then that comes 3 digit, then also we tried some bigger number. That is fair enough. We see that always the pattern is 1, so we can pick the answer as answer choice B, and we can eliminate all the other answer choice. So answer has to be here B, 1. The remainder is always 1. Now let's see what is the theory or what is the math behind this question, because here whenever we are dividing any prime number greater than 3 and we are dividing by 12, right? So we are getting the remainder as 1. So there should be some theory behind it. Let's see what is the theory. The theory is very simple. Any prime greater than 3 can be expressed as 6n plus or minus 1. So that's the reason when we square this and when we are dividing by 12, we are getting the remainder as 1. Okay, so let's understand what is the 6n plus or minus 1. So it is again very simple. It's a division rule. Whenever you divide any number by 6, right, according to the division rule, you can write like this. The dividend is always equivalent to the divisor into its quotient plus remainder. So always the remainder has to be here lesser than 6, right? The remainder cannot be greater than the divisor, so that means the remainder has to be lesser than 6. So what are the possibilities whenever you divide any number by 6? The remainder could be 0, 1, 2, 3, 4 or 5, right? But since we have a condition that any prime, the number has to be a prime, then the remainders are 0, 2, 4 and 3 are not possible. Because why 0 is not possible? Very simple. If you are getting the remainder as 0 when we are dividing by 6, it means that the number is divisible by 6. Prime number is divisible by 1 and itself. So prime number cannot be divisible by 6. So in that case, remainder 0 is not possible. How about 2? 2 means we are getting an even number. Only even prime only even prime which is possible is 2. All other prime numbers are odd. So 2 and 4 is also not possible. Let's check, let's try first few values so that we'll confirm what is it says. 2, 8. So when we divide 2 by 6, remainder is 2. When we divide 8 by 6, remainder is 2. 14, 20, 26. Likewise 4 and then we take 10, 16, 24, not 24, 22, then 28. All these when you divide by 6, right, this one you divide by 6, these 2, 8, 14, 20, you will get the remainder as 2, but all are even numbers and 2 is a prime number, but that's the reason we are kept here as any prime greater than 3. So that means this is not possible. Then what about here? When we divide any number here by 6, right, 4, 10, 16, 22 by 22 and 28 by 6, we will get the remainder as 4. And again, this all are even numbers, right? So which is not possible, right? Prime number cannot be other than 2. There are no other prime numbers which are even. So that means 2, 4 is also ruled out. So what about 3? If at all, right, for a 3 it has to be, right, remainder we get as 3, then it has to be divisible by 3. For an example, the numbers which will when you divide by 6 leaves the remainder as 3 is like 3, 9, 15, 21, 27, 33. Just write few values, you'll get the pattern. So if you look at it, all these numbers are divisible by 3. And of course 3 is a prime number. The first value which is 3 here, which is a prime number, that's the reason again we have kept the condition here greater than 3. So that means all these numbers are divisible by 3. Prime numbers cannot be divisible by other than 1 and itself. So that means we cannot have the remainder as 3 as well. So in that case, only possibilities are remainder could be 1 or 5. So that means we can express that, right, the number greater than 3 when we divide by 6 as 6n plus 1 or 6n plus 5. Okay, if this is your number, when you square it, you will have is 36n square, that is a plus b the whole square, a square plus b square, which is 1 plus 2ab, 2 into 6n, 12n, b is 1, so that means 12n. Similarly, 36n square plus 5 square, which is 25, plus 2 into 6 into 5, which is 30 into 2, 60, 60n. So this is what you express as. Now if you look at it, each and everything, 36n square is divisible by 12. This is also divisible by 12. This is a multiple of 12, 12 into n. And 36n square is also divisible by 12, right? 12 3s are 36. And this is also divisible by 12 because 12 5s are 60 and it's a multiple of 60. So that means of course it is divisible by 12. So whenever you divide 1 by 12, remainder is 1, and 25 by 12 you divide it, remainder is 1. So that's the reason we are getting always the remainder as 1. So that means whenever you see any prime number greater than 3 given in the question, you can always express that as 6n plus 1 or 6n plus 5. 6n plus 5. Why we have written this as minus 1 here is the negative remainder of plus y is minus 1. So that's why we have written as 6n plus or minus 1. Since GMAT does not test negative remainders, right? It is better to write 6n plus 1 or 6n plus 5. Let's not confuse something about negative reminders when it comes to GMAT, because GMAT is not going to test anything about negative reminders. So that's the reason here always when we are dividing this by 12, any prime number greater than 3 by 12 and squaring it, squaring and then dividing by 12, we are always getting the remainder as 1. I hope this is clear. Thank you.